Well, in the next set of notes, we're going to be looking at the phases of ventilation and then how we control ventilation. So let's just start with the mechanisms of breathing. So there's two phases of ventilation or your breathing. Inspiration is an active process of inhalation that brings air into the lungs. Expiration, a typically passive process of exhalation that expels air from the lungs. When you think about Boyle's law, ventilation is governed by this. So essentially, anytime you have a lower pressure, air will move from a high pressure to a low pressure. And so that is what draws the air in. So if the sides of the container move outward, the pressure lowers, and then the higher pressure air will move into the container. Anytime the size of the container is made smaller, we increase the air pressure so that it's higher than the outside, and then the air will move back out. So one thing that you will find is that with lungs, we will use the diaphragm and the intercostal muscles to contract. The diaphragm then flattens and the rib cage moves upward and outward, and the volume of the thoracic cavity in the lungs increases. The air pressure within the lungs then decreases and air flows into the lungs. So here you can see this with the intercostal muscles of the rib cage moving upward and outward, and the diaphragm moving downward. It just is a contraction. It's curved upward, and when it contracts, it flattens. And this allows us to increase the volume of the lungs, decreasing the pressure, and allowing air to move into the lungs. During expiration, the diaphragm and the intercostal muscles simply relax. The diaphragm moves upward and becomes dome-shaped. The rib cage moves downward and inward. This is a passive process. It doesn't require anything more than just relaxing, but it makes the volume of the thoracic cavity in the lungs decrease. So the air pressure within the lungs increases and the air flows out of the lungs. Here you're seeing that volume decreasing, increasing pressure, and forcing air out. You can measure how much air is being breathed by looking at some different pieces here. Tidal volume is just the amount of air that usually moves in and out with each breath. Typically, you don't expel all of the air in your lungs each time you exhale. In fact, you can't. So this is just looking at how much you exchange in any given breath. Vital capacity is the maximum amount of air that can be moved in, plus the maximum amount of air that can be moved out during each breath. So for example, if you take an extra deep breath and then an extra large exhale, this would be the vital capacity, which of course would be larger than if you're just breathing more normally. Then we can look at the inspiratory and expiratory reserve volume, and this is the increased volume of air that's moving in or out of the body. So we're looking at how much more air could be there. And then there's always a little bit of air remaining in the lungs after you exhale, and this is the residual volume. Every once in a while you can get some of this out of you, but it's only if you've fallen really hard and that feeling of having the wind knocked out of you, that residual volume has gone out, and it just makes it a little more difficult to take that next breath. If you visualize it, you can see here is our typical tidal volume of a normal breath. And here you can see that maximum inspiration and your maximum expiration, and that becomes your vital capacity. And then notice that you always have a little bit of residual volume of air in here, and that's your total lung capacity, the absolute most air that the lungs can hold. So when we think about how do we control breathing it's done by the nervous system. So there is a respiratory control center in the brain. This is called the medulla oblongata. And it does some other things, but it does help control breathing. And it sends out nerve impulses to contract muscles for inspiration. Now, one of the really tragic things that can happen is in a very young baby, when the brain isn't completely developed yet, you can get sudden infant death syndrome. And it's thought to occur when, for whatever reason, the medulla oblongata just doesn't send out those nerve signals like they should, and the baby just flat out stops breathing. When we start looking about it in the nervous system, you can see we've got the brain with the control center. We have that respiratory center that's located right back here. And then we have nerves going to the intercostal muscles. We also have the phrenic nerve that stimulates the diaphragm. Now, this phrenic nerve can sometimes be overstimulated and you'll get hiccups. Notice that the phrenic nerve goes right behind the esophagus. One bypass to that is to take something like honey that's very thick and very sweet, and sometimes that sugar will move across the esophagus and will get that phrenic nerve to trigger out of it. Now, what's interesting about breathing is you can consciously control your breathing, but if you stop paying attention to it, your brain will go ahead and go on autopilot and take that back over again. There's a couple of things that happen with control of your breathing. You have chemoreceptors, which are chemical controls, and there's two sets. You have one in the brain and one in the circulatory system. And essentially what they do is they notice if your blood becomes acidic. You don't have any kind of an oxygen sensor in your body. All you have is a carbon dioxide sensor. So if carbon dioxide levels get too high, your pH of your blood will change. It becomes more acidic, and that is what the chemoreceptors are responding to, and it will cause you to increase your ventilation.